One of the problems that requires the largest amount of resources is the prediction of climate change for the near future. What we are doing is we have developed a global climate model that runs on a machine like the one we have here, Mare Nostrum 4. That model represents the evolution in time of the ocean, the atmosphere, the sea ice, the biosphere, all coupled together. And this is fundamental because we know that changes in the soil moisture, for instance, in continental areas, are affecting precipitation a bit farther east. We know also that changes in the ocean are affecting the atmosphere and so on. We have to reproduce what happens at the global scale in many different systems and for a very long time. So this is a very intense computational problem, which at the same time is producing a huge amount of data. What we do, apart from simulating and storing this data, is transforming this data into a piece of climate information that can be ingested by the wind farm investors, by the food production managers, and by many other sectors. We don't sell services because we are part of the public administration. What we do is we try to identify opportunities that can be put into the fore. So right now, this is a service that institutions like the BSC are providing to the global community in collaboration with the Met Services of Canada, the UK and Germany. Collaboration is critical in climate and weather and air quality research. The reason is that climate and weather is not local. It's a global problem. One cannot really predict what the weather is going to be like in Barcelona for the next 5 days without knowing what happens in the North Atlantic or what happens with high pressures or low pressures near Greenland. So this enterprise is only possible if data is exchanged fast, open and freely. We have estimates of the climate change for the next 10 years. This is part of an initiative that the World Meteorological Organization has created and sponsored, in which the BSC is a critical part in the provision of the data that are being used. We have a probability of 10 to 20% of 1 year in the next 10 years to have a mean temperature of 1.5 degrees warmer than the 19th century. This global climate model has a limited precision in the sense that it cannot tell us exactly what is going to happen in the next 5 years, but is much better than guessing that the future is going to be like the past, because we know it's not the case. The climate is changing now. Digital Future Society is very important in the sense that it is targeting the impacts that digital technologies and emerging technologies might have. Somehow we need these kind of initiatives that are emerging from the digital world itself to make understandable the kind of problems, social problems like the one I work on, climate change and air quality problems, to the digital world itself. So it's only an internal initiative that can really translate what people like me, researchers, are doing into a vocabulary and a language that is understandable by this community.